Now we're going to analyze qualitative graphs and summarize the situation each graph represents. Let's take a look at this problem and then explore different ways to help interpret the graph. It says students in Mr. Blanco's class have 3 weeks to complete their science projects. These graphs show how much of the project 2 students have completed each day during this 3-week period. Describe what each graph shows. So first, what is this problem about? It's about the students in Mr. Blanco's class completing their science projects. Now, what are we trying to find out? It's asking us to describe, that's our do word, describe what each graph shows. Now, what information is important in this problem that will help us describe each graph? Know that these 2 graphs here show how much of the project that Lynn and Amy have completed each day for 3 weeks. So before we do anything, let's analyze. Let's divide these 2 graphs into 3 equal vertical sections. Okay, so I'm going to divide my graph here. I'm going to divide my graph here because I want to have 3 equal weeks, okay? Because right now there's no number labeling. This is a qualitative graph, so I have to really envision splitting this up into 3 weeks for Lynn and also splitting it and dividing this up into 3 weeks for Amy as well. Before we analyze it, this graph we know shows a 3-week period. So imagine the graphs divided into thirds vertically. Okay, so Lynn's graph, the first third of the graph, is steep. The second third shows a gradual increase and begins to straighten out. And then the third section is almost straight, or a horizontal line. It runs parallel to this x-axis. So I'm going to do the same thing for Amy. Okay, so the third section, so let's take a look at Lynn's again. The first third of the graph is pretty steep. Our second third shows a gradual increase right here, this little curve, and then it begins to straighten out right here. Then that third section is almost as straight as a horizontal line. Okay, let's take a look at Amy's graph now. We're dividing it into thirds. The first and second part of her graph shows a line that's pretty close to being straight. Then we look at the third section and it's, whoa, steep. So let's interpret it. What does that mean? Okay, so we can use the graph. Let's use our analysis of our graph so far and describe each of the graphs. Each of these thirds represent 1 week. So here's week 1, here's week 2, and here's week 3. Again, week 1, week 2, week 3. Again, this is a qualitative graph, so you're not going to see any numbers down here. And you're not going to see any numbers on the side here, and you're not going to see any numbers on the side here. But we do have labels. We have our time in weeks, and we have the amount of science project completed. So I can already tell that Lynn's graph is steep the first third and somewhat flat the rest. That means that she did most of the work on her science project on the first week right here. Amy's graph is the opposite. The steep action that happens is right about here in that last third of her project. So she did most of her work on the project the 3rd week. So how are these graphs similar to the graphs that you worked with in earlier lessons? How are they different? And what are some of the reasons for the differences? Some of our graphs in other lessons included numbers on the axes and exact points. So we saw dots and plots. Most of those graphs represented solutions to an equation that defined a relationship between 2 variables. The graphs on this lesson also represent a relationship between 2 variables, but there is no mathematical rule for these graphs. The graphs are visual representations. That means these graphs don't have equations. They're just visual representations of a situation that can be used, that can be described visually. Now let's solve a problem similar to the one that we saw on the previous page. We're on page 93 in our student textbook now. The problem says the graph shows daily sales of frozen yogurt at a new store during a 6-month period starting on opening day in April. Describe what is happening in terms of the situation for each section of the graph. Okay, so different sections are going to match up with different letters. So here's section A, here's section B, here's section C, and here's section D. So let's remember that in this graph, okay, the yogurt stand opened in April. Okay, notice that when we consider each section, we might want to consider each month or time of the year that the section corresponds to. So let's look at the difference between positive and negative slopes and what they represent in a situation. Let's look at the steepness of the slopes as we make some interpretations of this graph. Okay, so let's look at section A, describe and interpret section A. The graph starts at 0 and then it increases gradually. So this is still April. So the store probably just opened, and the sales, okay, over time, over this short time right here, the sales started increasing. Okay, so this is the frozen yogurt sales. So we're making some money. The more money we make, the higher this line's going to go. So let's look at section B. It's steep, very steep. It's steeper than section A. Okay, it's steep and has a steep increase because this is probably where summer starts. So we have April to probably the beginning of June, and then it skyrockets and shoots up in June. Okay, so summer's starting, so more people are going to be eating that froyo. Then we have section C, where we kind of plateau. Okay, so this section's kind of flat. Sales are probably consistent during the summer, so they're still making money, okay, and they're still probably making money here, but the sales aren't increasing. They're just making that money right now. They're making that chitta. Okay, and then in section D, notice how this part shows a decrease. The sales are decreasing because this is probably, let's see, June, July. This is probably August. Okay, August, September. So the weather starts getting a little bit colder. Probably not in Myrtle Beach, but everywhere else, the weather probably cools down a little bit. Okay, so let's summarize what this graph shows. So here, the graph increases gradually, and then as the weather warms up, that sale increases. Then we stay about the same for the summer, and then we decrease in colder weather, and then we kind of flatten out here, kind of like in October. On a shot. Yes, the directions say use what you've learned about qualitative graphs to solve this problem. Show your work on a separate sheet of paper. Number 7 says summarize the graph showing gasoline prices. Let's take a look at this graph. Okay, before we even start, I'm going to address a major misconception or something that we make a lot of errors for. Where this flat line's right here, where we don't see an increase or decrease, right here, right here, right here, and right here, okay? Those prices don't change. There is no change of price over time. That means that price stays the same. It's constantly the same, okay? So let's take a look at it. Right here, we say the price of gasoline remains the same for a while. Then it decreases, which is a good thing. Gas prices are decreasing, okay? And then if it decreases, it stops there, but it doesn't stop. It just stays there for a while, okay? So over time, this gas price is as low as it can go. It stays right there. Then after a while, we have a greater increase, Okay, so this increase is higher than where we even started off. So the gas prices increase, which means the people who are driving are paying a lot more money for that gas. The prices rose to the highest over the period. Okay, so this is the highest it's ever been. And it stays there. It remains that constant. It doesn't change. Okay, so these gases shoot up. The gas price shoots up and it stays up there for a really long time. Then gradually it drops off for a little bit right here. And then where it drops off, it stays steady right here towards the end at about the same place as probably the starting price. Okay, so this is where we started. This is where we ended up. Okay, this is our price of gasoline. Notice how it stays almost right there from where it is in the beginning. Okay, so we might need to divide the graph up into vertical sections in order to analyze each of these sections as well. In this section right here, that graph remains the same for a while. Then it decreased over a small amount of time. It decreased and it stayed steady for a certain amount of time right here. No, over another small amount of time, the prices increased to where it was before, but then it skyrocketed and rose even higher than where we started over a certain period. Then it stayed over a certain amount of time, it stayed steady at that high price right there. We had a slight drop over time, and it kind of held steady right here after it gradually dropped. And we matched that along with probably similar to where it started off in the price. Okay, so over time, our prices decreased, then it increased, and then it kind of stayed steady towards the end, rounding us off to where we were in the beginning. Let's review what a function is. We know that a function is a relationship in which there's exactly one output for each input. So here, my output is that amount of time. My input is the price of gasoline. So over time, after a month, after 2 months, even with a yogurt stand, let's take a look at the yogurt, okay? Even after April, maybe May, June, over time, we don't know exactly what this is, the sales increase. So my output increases, okay? Same goes for my other graphs. My input is my time, okay? So over time, what happens? The amount of science project becomes completed, okay? My input up here is my time. Once again, notice the pattern. My distance increases. That's my output. So for the longer I go in my time, the more of my distance is going to increase. So for any given time, could there be more than one possible output? And is this a function? And at any time during this 3-week period, the girls can only have one amount. Let's take a look at this problem right here. Okay, for any given time, could there be more than one possible output? At any given time during the 3-week period for both girls, they can only have one amount of work done. Meaning, like for this time right here, they can only have one amount for work done here. It's impossible for one person to have 2 different amounts of work. If that was possible, you'd see 2 lines on Lynn's graph. Except there is no 2 lines, there's only one output. So the girls can only have one amount of work done. It's impossible for one person to have 2 amounts of work done at the same time. Therefore, the relationship here is a function. This relationship is also a function. So it doesn't have to be just straight, jagged lines. It can also be curved lines, and it can also be functions, as long as the lines do not intersect each other. Every line that we've looked at on every graph shows and depicts a function.